Good morning. So, in the last class, I told you regarding one example which I will going to discuss it today. Okay, I'll read out the statement of that example, and I think all of you have gone through that, say, notes or the PPTs which I have sent. Now, we'll discuss regarding that particular example. I'll read out the statement. Two channels, one with bitrate 100 kbps and another with bitrate 200 kbps are to be multiplexed. Okay, the given thing is that we have two channels. One is with 100 kbps, the second one is 200 kbps. Yes, I have a two channels. One is 100 kbps and another is 200 kbps. We need to multiplex these two to generate the required output or utilize the bandwidth of the link. Okay, now what is asked is what is the frame rate, what is the frame duration, what is the bit rate of the link. So whenever they say a bit rate of the link, it is connected with this. Okay, what is the frame rate? I'll write those things. What is the frame rate? How many number of frames that are generated per second? That is a frame rate. Second one is what is the bit frame duration. Once if you know the rate, easy to find the duration. Okay, and last one is what is the bit rate of the link. So they are talking regarding bit rate of this link. Bit rate of link. Fine. So these are the three questions we need to answer in connection with this particular example. So I have two links. One link is of 100 kbps and a second link is of 200 kbps. Okay. Now there is a mismatch in the speed. Mismatch in the data rate. So what should I do? Yesterday we discussed three techniques. One is multi-level and second one is multiple slot. The third one is pulse stuffing. These are the three techniques when we encounter these type of situations to deal with it. Okay. So you know that in multi-level, say when I have a multiple links whose rate is say smaller compared to the one which is already there. In this situation we talk of using a multiplexer to multiplex them and apply it to this. Okay, and in the second case, okay, when I talk of a situation one which is mentioned in your example where I have two links with one with 100 kbps and another one with 200 kbps. Now look at the option here. Look at the options. I don't have a multiple links to club them to bring it to this level. I have only these two options. Here I have only an option of splitting this into 100 kbps. Okay, I have only one option of splitting this 200 kbps into a multiple 100 kbps things. Okay, so 200 kbps I am going to represent it as 200 kbps. Okay, so basically this act of converting this 200 to a 100 links 100 capacity is by with the help of demultiplexing. Okay, now what I did is I clubbed these two. Okay, I am going to club these two. I will going to demultiplex the 200 kbps into 2. So practically speaking, what exactly we are doing here is we are talking of reserving multiple frames for higher rate input. Okay, now see, here it is 100 kbps, here it is 200 kbps. When it comes to a 200 kbps link, we will going to reserve multiple slots in the frame for it. Normally, this frame will going to be provided one slot in a frame for every link, every input. Okay, when I talk of a frame, normally this frame will going to contain a slots for every input link, so one slot will going to be reserved for one link, one input link. Okay, now when it comes to these type of a situation where I have a capacity, more capacity compared to the other inputs, so in this situation we will going to reserve multiple slots for this particular input. Okay, this particular input will going to have multiple slots in the frame. Now see, actually I need a frame with 3 slots. One is for this link, okay, this will be for this, and other 2 links. Now I mean the other 2 slots will be for a link with 200 kbps capacity. Actually it is linked with 200 kbps capacity. For understanding reason I am just splitting it into a 2 and representing it. Okay, so this is how we will going to do it. Okay, so these 2 slots will be reserved for second link. Okay, so this is how I can accommodate the data into the frame. I will accommodate the data into the frame. Okay, so this is the way you need to send the data. Fine, I hope it is clear to you all. So now based on this idea I have to solve those 3 bits. Okay, so what is the first question asked? What is the frame rate? Okay, what is the first question? That is the frame rate. Okay, as you know that, okay, I told you one simple trick in the last class, that whatever the input link speed, okay, if all of them are having the same value, so you have to pick that. Okay, that itself will going to be your, say, frame rate. Okay, normally frame rate is same as that of the input value. Okay, I just told you the situation. This is the situation. Okay, so how exactly you have to handle it? Fine, so it is 100 kbps, I mean 100 kilo frames per second, sorry, 100k frames per second. Okay, this is frame rate, 100k frames per second, or otherwise you can write it like this, 10,000 frames per second, one and the same. Okay, it is not 10,000, it is 100 frames, not 10,000, sorry, it's 100 frames per second, 100,000 frames per second, 100,000 frames per second. Yes, and second bit is that what is the frame duration. Okay, now the second question which is asked is what is the frame duration. Now when you know that how many number of frames are getting generated per second, so frame duration is very easy to find it out. Okay, it is 1 divided by frame rate, 1 divided by frame rate, that is, okay, so this will be your frame duration. It comes somewhere around, say, 10 milliseconds, comes somewhere around 10 milliseconds. This is your frame duration. And last one is, that is, what is the bit duration, what is the bit rate on the link. Now see how many inputs you are actually clubbing here. So 3 inputs of 100 kbps, okay, you are multiplexing them. So that means whatever the frame rate you have, that is, frame rate is 100 kilo frames per second, 100k frames per second. Yes, this into number of inputs. How many inputs? It is 3. So this will going to give you the bit rate on the output link, that is 300 kilobits per second will be the output bit rate. Okay, so this is how you need to work. Okay, so this is an example which is connected with your, say, those three techniques of dealing with mismatched data rate, mismatched input data rate. Okay, now next I am going to discuss regarding the spread spectrum. Spread spectrum. Now look at the statement. I am talking of, say, spreading the bandwidth of some signal. Okay, basically I am talking of increasing its spectrum. Spectrum increase in the sense it is increasing of its bandwidth. Okay, now basically what exactly it means. Okay, so you know that in multiplexing what we are doing, actually we are clubbing multiple link input lines to utilize the bandwidth of the link in an efficient way. So most of the times we have a situation where our output link bandwidth will going to be more than that of our input lines. So to utilize the bandwidth of this output link in an efficient way, we use the technique of multiplexing. But when it comes to the spread spectrum, okay, you see here too we are talking of, say, clubbing or the action one, which is that what we have discussed in the multiplexing. Here also we are doing the similar kind of a thing, but the purpose of, say, mixing here is totally different compared to that of the multiplexing. Okay, so here too we are talking of, say, combining the signals from different sources. Okay, but the purpose is slightly different. Now to know regarding the purpose why we want this spread spectrum technique, okay, first you should look for, or you should understand what exactly happens in the LAN and WAN. Now when I talk of local area network, one which is working on wireless, one which is working with the wireless. Okay, now in this wireless LAN or wireless WAN, what happens? The medium for communication is air. We use air or the vacuum, okay, as a medium for communication. We don't use any kind of a cables over here. That is the reason we call it as a wireless. Okay, but we need some kind of a medium for transmitting our signals from one end to another end, or from one machine to another machine. We use, in those cases, we use air or a vacuum as a medium for transmission. Okay, but when we talk of, say, these type of mediums which is allowed to be accessed by anybody, okay, there is a lot of threat of security. Okay, some eavesdropper may, say, listen to the communication between two devices. Eavesdropper in the sense the person who is sitting in between, who wants to listen to the communication that is happening between two devices, say station A, station B, okay, when they are communicating in the wireless medium, okay, through air. So there is a possibility that some third person may listen to these people's communication. He will be called as a eavesdropper. He may listen to the communication. Okay, there is a possibility that some people, the harmful people, may jam this link, or they may go for jamming of this communication. Okay, that we call it as denial of service kind of a thing. Okay, so these type of acts we want to stop when it comes to this type of environment where, say, everybody is allowed to utilize the same medium simultaneously, when there is no restriction for the users to utilize that medium. Okay, now see, in what happens in a guided media, especially in cables and all, okay, at least we can have a way in which the signal is required to be sent. We are providing a path for a signal to travel in some direction. But when it comes to this type of environment, okay, so normally in wireless, you see, when I talk about this wireless device, it radiates the signal in all directions. There is a possibility one who is sitting over here may listen to the communication. Whatever the message that is sent over here may also reach him. He may come to know what exactly is going on. Or if he is say some bad guy, okay, he may utilize this message for some wrong activities. Okay, so to avoid these type of things, or to work to block these type of activities, we use the kind of a technique known as a spread spectrum technique. So in short, okay, in short, my spread spectrum, okay, so we're going to be look like this, where so I'm going to have something known as spreading process, okay, which will going to spread the bandwidth of input. This is my input signal. See, I am talking here about the signal. I am not going to do anything with the input. My input will going to generate this signal as it is, okay, but we are not modifying the input so to perform this task, spreading of its bandwidth on, say, increasing its bandwidth and all, okay. But when it comes to the output, look at the bandwidth of the output, it will going to be more than that of a input. So this is the bandwidth of input, this is the bandwidth of output. I increase the bandwidth of input when it comes to utilizing the medium. So that means indirectly you are asking for the medium which should support more bandwidth than that of the input signal. Yes, it is a kind of, say, reverse action that what we have seen in the multiplexing. Actually, while discussing this particular topic, I said this action is similar to that of multiplexing, but when you look at this figure, okay, you may feel that, okay, in multiplexing we are trying to utilize these things, we are trying to club multiple things to create large bandwidth signal, but whereas in case of spread spectrum, I'm talking of increasing it. How exactly we're going to mix it? Basically, in this case, okay, I will going to mix some spreading signals or spreading code, okay, depending on technique. So I am going to talk of mixing it with this spread process, and with the help of this spread process, I am going to mix this with the input so that to increase its bandwidth. Now see, when you look at this task of mixing these things to increase its bandwidth, this is somewhat similar to your multiplexing. But when you see, when you look this whole task only from this input signals point of view, the action somewhat looks funny. Yes, say you are talking of, say, one which has a lower bandwidth, you are forcing it to utilize a larger bandwidth, okay. But when you look at these two things, this particular task of mixing or multiplexing these two signals is same as that of your mux, okay. Now what exactly we do over here, okay, so before going for that particular discussion how exactly to be done this, so first I'll say list out different techniques that are used in a spread spectrum case. So we have two methods. One is an analog one, we call it as frequency hopping spread spectrum, FHSS. Frequency hopping, you know it, okay, spread spectrum. And second one is DSSS, okay, direct sequence spread spectrum, direct sequence spread spectrum. So this is a digital process, this is a digital process, and whereas this is an analog process, this is an analog process, okay. One is digital and another one is analog. Frequency hopping spread spectrum is an analog process, DSSS is a digital process. Now we will see how exactly FHSS performs the task of spreading the spectrum, okay. So what happens in a FHSS, you know that. So I'm going to have a mux multiplexer, I mean a multiplier. I'm going to have a multiplier. You know that this multiplier is, already we have come across this term in ASK, FSK topic. So basically it is meant for multiplying two different signals, okay. So I'm going to have some signal over here, input, or you can call it as, say, some kind of a output from some input source, okay. or it may be a signal that is generated by multiple outputs, multiple input sources. So rather than calling it as input signal, I am going to call it as the output signal. Okay, I am going to call it as output signal from some source. Okay, so I am going to have a frequency synthesizer. It is nothing but your oscillator, which is capable of generating different oscillating frequencies, which is capable of generating multiple oscillating frequencies. That is the reason I will going to call it as FS, frequency synthesizer. Okay, so this is my frequency synthesizer. So no space, I'll leave it over there. Okay, synthesizer. Next is the output. What you will going to get? It is the spreaded signal. It will going to be a spread signal. Okay, it will be your spread signal. Okay, so I think it is visible. It is your spread signal. Okay, so these are the arrangement that are what we used in spreading technique. Okay, now I will going to talk regarding the bandwidth of this signal. I am going to call the bandwidth of this is BSSS. I am going to call the bandwidth of this signal is B. So what is the requirement is my BSS should be greater than, very much greater than B. Okay. Now what exactly this frequency hopping means? Okay, I am talking regarding a frequency hopping technique. I told you the figure. I need an oscillator which is capable of generating multiple oscillation frequencies. Okay, and the 6 frequencies which are generated by it will going to be multiplied with my signal which is generated by some input source. Okay, so then we are creating the spreaded signal. Now what will be an input to this FS? How exactly it will going to generate the different oscillating frequencies? We need to have some way to trigger it. Okay, so for this what I will do is I am going to use one lookup table. You look at here. Okay, this table will going to have a list of frequencies like this: 100 kilohertz, 200, 300, and so on. And this is a lookup table. So we're going to have some serial number for these things. Yes, and then you see I'm going to have something known as some random number generator. Okay, some random number generator, that is nothing but pseudo random generator. Pseudo random generator. That is my pseudo random generator. It is one system which generates some random numbers which are in the range of these values. Here, because of the space reason, I have only shown 3, but actually you want to have multiple such values. Okay, for understanding reason, I will talk regarding say 0 to 7. I talk regarding 0 to 7. I have say at 4 you're going to have a 400 kilohertz, at 5 serial number 5 you're going to have a 5, and so on. Okay, now what exactly this pseudo random generator? It will going to generate a number which is in this range, which is in the range of 0 to 7. Okay, this is an example. Normally it will not be such a small range. It will be, this list will be bit bigger. This list will be bigger. Okay, so whatever the number it generates, that generated number will going to be inputted to this say a lookup table. Based on this inputted value, okay, say for example if it has inputted 02, okay, so this 02 will help us to pick this frequency of 200 kilohertz. So 200 kilohertz will go to be input for this frequency synthesizer. Based on this number, the frequency synthesizer will go to generate 200 kilohertz carrier signal, which will now going to be multiplied with this signal. Okay, now there is a multiplication of a signal with this 200 kilohertz carrier. So the output, you see, the first output what you are generating is of 200 k. Okay, when you perform this, you will going to generate a signal with 200 kilohertz output. So this particular generated value will going to last only for a few seconds of time. Okay, its duration is very small. Thereafter, again pseudo random generator generates a new number. Yes, that new number will going to make it to select a new frequency. Okay, now what happens? Say this is what is the action that is happened at t seconds, t1 second. Okay, for a duration of t1 seconds, it has generated a 200k. But after t1 second gets completed, pseudo random generates a new number that will go to pick another one frequency. Say for example it is 500. So next in the next time instant, if this pseudo random generator generates a 5, so 500k will be picked from the table and it will be inputted to frequency synthesizer. Now frequency synthesizer will go to generate 500k carrier. Now what happened? You see the same signal which is over here initially for a t1 seconds, for a during a t1 duration, during d1 duration, okay, during t1 duration, okay, what it is doing is it is generating 200 kilohertz signal for t1 duration, but in t2 duration the new number got generated. That new number is 5, so it makes it to use 500 kilohertz carrier to generate the modulated signal. Now what happens? For a t2 duration, you are generating a signal whose range is 500 kilohertz. Okay, whose carrier is 500 kilohertz. So that means naturally output signal will be placed in this particular band. Okay, and at t3 duration, what happens? Again, new number will going to be generated. Say consider t3, if it is 300 kilohertz. Okay, so then your signal will going to be modulated with the help of 300 kilohertz carrier. So like this, you are using different carriers at different time intervals. Now say same input signal is now modulated initially with this, then with this, then with this. So what happens? By doing so, you are, when you look at the frequency for this particular duration from t1 to t3, when you look for the bandwidth, okay, the range of frequencies that you used from t1 to t3 is 100, 300 and 500. You see, these are the three frequencies you used. When I say these are the three frequencies used from t1 to t3, what is the bandwidth? Bandwidth is 100 minus 500. It is nothing but 400 kilohertz. Your bandwidth is so large. Now see, your signal only needs 100 kilohertz bandwidth, but you are spreading it across 400 kilohertz bandwidth. The minimum value is 100, maximum value is 500. So the range is, now the bandwidth is increased to 400 kilohertz. Now what happened here is, these durations t1, t2, t3, they are a shorter one. Only for a short duration it is in this range, it is using this, and again almost of the same value, okay, duration is same, so for that you are using a 500. So like this you are using a different range of frequencies, which confuses the hacker or the person who is trying to listen or trying to do something with this type of a communication. It confuses him, so he don't know, he will not come to know which is the carrier frequency that will be used to transmit it. Even somehow if he comes to know that, okay, that he is using 200 kilohertz, but how much information he will going to get? Only very small information he will going to get out of the whole information. Okay, so by doing so you are hiding the information. Okay, so normally this is basically for security reasons. Okay, this technique is basically for security reasons. Naturally question arises, you are wasting the bandwidth. Yes, so we are wasting the bandwidth, but normally what they do is, I have explained this whole task only for one system. Okay, there is a possibility they may use such a multiple input signals with the help of pseudo random generator, and whatever the number it generates, the second pseudo random number will not go, second pseudo random generator will not going to generate it. Okay, say for example if it generates say some number, okay, So next pseudo random generator will going to select, say for example we have yum systems. Okay, whatever the first pseudo random generator generates, that number will going to be excluded from this m, and the second pseudo random generator will going to generate a number which will be excluding this number, and it will generate a new number which will going to select a new frequency. So that new frequency will going to be used for new systems. So you can use this technique along with the multiplexing to utilize the bandwidth in a better way. Okay, now see, if I have a situation like this, I have multiple input links like this, I'm going to use, okay, I'm going to use, say, multiple pseudo random generator, or otherwise you use some kind of arrangement using a single random generator, pseudo random generator. Let it generate multiple random numbers simultaneously. Let it generate multiple random numbers simultaneously for a t1 duration, and all those numbers must not be same. Okay, if this is a condition, if you are putting, so what happens, you are applying, say, some signal. I'm going to call it as S1 is my carrier, S2 will going to be carrier for this, S3 will going to be carrier for this, based on pseudo random numbers generated value. Okay, so now these three are now, say, modulated using three different signals, three different frequency signals, and they in turn get multiplexed together. Okay, so this is how I can utilize the bandwidth in an efficient way with the help of multiple input signals. Okay, so that I can, say, overcome the problem that was, say, underutilization of the bandwidth. I hope it is clear to you all. Okay, now I will ask you to enter your USN in the comment section. Now the time is it is 9:39. So now you enter your USN again in the comment section. Based on that, I will come to know how many have attended or how many are still there in the class. Okay, please attend, please enter your USN in the comment section fast. Yes, please do it. Don't write your name. Your USN is enough. I will come to know who all are entering the USNs. Okay, thank you very much. So I am going to discuss regarding the next topic, that is DSS. Okay, direct sequence spread spectrum. So this is the last part of this. Okay, last part of this multiplexing chapter or bandwidth utilization chapter. So in what happens in DSSS? Okay, as I said, it is a digital technique. So when I talk of digital technique, so bandwidth will be expressed in bits per second in digital systems. Okay, in analog systems we express the bandwidth in terms of hertz or kilohertz depending on the situation. But when it comes to a digital techniques, we express, or a digital systems, we express the bandwidth in terms of bits per second. Okay, now what exactly happens in DSSS? Okay, so in DSSS I need a support of signal. So to understand this, okay, I'll talk of using some simple NRZ signal. Okay, this is my NRZ signal. Hope it is visible. So it is my NRZ signal. So this is 1, this is 0. So now what we will going to do is, I will talk of increasing its bandwidth with the help of digital technique. The technique is what? Again, you see, I will talk of using some kind of a signal like this. Okay, so this is a signal which now will going to be multiplied with this. Okay, say this is 1, this is 0, this is 1, this is 0, and 1, 1. So this is my signal which will going to be multiplied with this. If I multiply this 1 with this, the outcome will going to remain same. But when it comes to a 0, the values will going to be reversed. Okay, so what I am doing is, I am talking of, say, a signal, one which has higher bit rate compared to that of the input. I am multiplying that with this. I am multiplying that with this input. Okay. So this, what we call it as chip code. We call it as chip code. Okay. I hope it is clear to you. So what we are doing here is, we are talking of, say, replacing your data bit with the help of n bit code. So in general it is n bit code. Okay, this is your n bit code. You are replacing your 1 bit by n bits. You are replacing your 1 by n bits. So this n bit code, okay, normally we refer it as chip code or chips. Simply if you say chips. Okay, so this chip code is helping us to increase the data rate. Say every 1 bit is now going to be represented by more number of bits. Say in this case it is 2, 4, 6 bits. Okay, so your bit rate is getting increased by 6 times. So bandwidth is increased by 6 times. Okay, so that is how you are increasing its bandwidth. Okay, so number of bits per second generated will going to be more if I multiply this with this. Same is the case with 0 also. As I said, the actions will going to be different. Say 1 will going to be 0, so this becomes a 0 here. Yes, this is 0, then this 0 will going to become 1 when I multiply that. Okay, so it will be like that. So you try that at home. So your output will going to be n times that is of the input, because your chip code is of the length n bit. Normally for these type of activities we use some special code known as a Barker code. Barker code. So this is a code. This is a normally a special code which is of the size 11 bits. Normally there will be a Barker chip code which will be used for this particular task. So this 11-bit code will going to be multiplied with your input. Most of the time this Barker code is widely preferred to carry out this DSS activity. Okay, direct sequence spread spectrum activity. I hope it is clear to you all. Okay, so basically these are two techniques, okay, which will be widely used for security reasons. And actually the question arises, how exactly DSSS utilizes the complete channel bandwidth. Okay, anyway, that topic, how exactly DSSS utilizes the bandwidth. Say we have explained for FHSS, okay, whether DSSS can be multiplexed or not. It is also possible to be multiplexed. But again, that topic I am not going to discuss it right now over here. In channelization topic, I will talk regarding that. And I will also tell you how exactly this Barker codes will going to be generated there. Okay, so in channelization topic, I am going to discuss regarding the same in detail. Okay, not DSSS, how to utilize the bandwidth with the help of, okay, this large sequence of bits. Okay, so that I am going to discuss it in that particular topic. I hope it is clear to you all. So this completes multiplexing topic. Okay, bandwidth utilization and multiplexing topic is completed. If you had any queries, if you had any doubts, you are free to discuss. Okay, so it is not possible to interact over here. Even in case if you have any doubts, you are free to put your doubts in a, say, comment section. I can read the comments. Okay, you are free to put your say doubts in comment section. Okay, and one of the student, I don't know the name, even if I know her name, I'm not going to take, I don't know. So they asked that question, that whether you are not comfortable with the YouTube or what. I am very much comfortable with YouTube. So the problem here is that lights. I can't change. Now see, you know the situation, it is a lockdown case, and even to find an electrician to change the light location is also a bit difficult task. Okay, and when you see these videos, there is some light issue which will not make you to see these things that are written on the board. So when I am writing, I can see it very clearly, but when camera starts capturing it, there will be a certain light issues. Okay, so and again I am working with mobile camera. Yes, these are my limitations where say I have a certain problems. Okay, that is the reason why many a times we move to that say your Google Meet. Anyway, from Monday onwards, we're going to discuss all these things through our Microsoft Meet. Okay, now from Monday onwards, most probably most of us or all of us will going to shift to a new platform, that is Microsoft Meet. Anyway, we are also created some kind of a studio in the college which is meant for these type of activities. So rather than talking or discussing in live, we're going to say prepare a shorter videos so that you can enjoy those short videos, short duration videos, okay, with proper arrangement and all. Okay, so those videos we'll try to post it to you. Okay, we have created a studio in a college. Okay, yesterday I experimented that. Okay, so anyway, this is all about say bandwidth utilization. In the next class we'll go to talk regarding a new topic. Almost the second module is complete now. Okay, so in the next class I'm going to discuss regarding the new module. I hope it is clear to you all. Okay, thank you very much. I'll end the stream. If you had any doubt, you can put your doubt in a comment section. I will try to reply to them. Okay, in YouTube comment section you write, or otherwise you send a WhatsApp message to me. I'm very happy to answer back to you all. Okay, thank you very much. I'll end the stream.